Hello, everybody. We'll wait for a few seconds that people come into the Zoom session or find their link on YouTube. Yeah, so some people are still coming, maybe one, yeah, not 1 minute, but a few seconds more. And then we start. So welcome, everybody. We have the pleasure today to welcome Michel Herquet for this second webinar on AI4GOV. So you have 5 seminars that will lead to the organization of an hackathon. The first one was a general introduction on AI application within the public services. We have today Michel Herquet, who is the CEO of B12 Consulting, who will present us the open source tools that are available that you could use in order to develop your AI solutions. And then we will have a seminar on data governance by Stephen Lattre, another on AI ethics and law that is also a very important topic and under many discussion at the moment at different level, but at the European level. And we will conclude this series of seminar with the intervention of Colin Van Noort from GRC to have a general overview on the maturity of AI application within the public services and the general roadmap. So thank you so much, Michel, to be here. We have many registrants, many people in the Zoom, many people on YouTube. And now the floors will be yours in a few seconds. You will have 45 minutes to present. Please do not hesitate to ask your question in the chat, either on YouTube or in the Zoom. And after your presentation, Michel, we will have a Q&A session. So thank you for being there, and the floor is yours.
Thank you so much, Nathanael. It's really a great pleasure to be here today to discuss and to present 2 topics which are really of great interest for me, both open source software development and artificial intelligence. Just before starting, I would like to know a little bit more about the audience, about you guys who are currently watching your screen. So I'm going to use a tool which is called WooClap, which allows a little bit of interactivity to ask you a few questions. So I'm going to display right now the information to connect to the tool. You have a different way of using this tool, but the simplest way is just to browse to wooclap.com and enter the event code, which for this session will be OS4AI. Or you can also use the QR code, which is there to connect to this session. So I see that there are already 20, 30 people joining. I will wait just a little bit more to make sure that everybody is on board before actually asking the first question. Yeah, it seems quite a few people are joining. Okay. 10 more seconds and we'll be starting with the first questions. Let's go. Okay. So the first question is really a simple one to know a little bit more about you. It's just to ask you where you guys are coming from. Different possibilities, public sector, private sector, academia, or others I might not have thought about. A lot of people coming from the public sector, makes a lot of sense for this session. And here we go. That was quick. If I can open it again, if you want to vote a bit more, so that all of you who didn't have a chance to vote can do it. Yeah, so I think we have a pretty good distribution of people joining. Most people coming from public sector, 25 from private, and 14 from academia. The next question is really about your current level of expertise in AI, and I, randomly defined 4 levels. And then just encourage you to tell me a little bit more about your current level of expertise in AI, so that I know how to focus the presentation which is coming. Okay, that sounds also a quite reasonable distribution. Quite a few experts, and let me open it again. Quite a few experts and advanced people, but the vast majority of people joining are beginners. So that will really be the focus of my presentation. I will focus on people with a beginner profile for this presentation. Okay, so sorry for the most experts amongst you who might find this a little bit too basic, but I will focus to make it available and accessible to beginners. Okay, third question, and then we have a good view of the audience. Do you currently use open source tools? Not necessarily in AI, I would say more generally. Do you use open source tools, either software development libraries, name it? Okay. Seems like a lot of people have voted. Large majority of you are actually using open source tools every day, which is most probably true. Few the ones often, sometimes, or rarely. Okay. And last but not least, I'm going to ask a more open question where you can write open answers. Why do you use open source tools? Just in 1 word or 2 words or several words, whatever, and you can submit different answer. Just tell me a little bit why you are actually using open source tools, and you can vote if you want to, to add some visibility. Great, I see community, I see the cost. No choice, okay. Why support it? Capable. Great. I think this deserves a few more seconds if you want to add your voice to the debate. Wow, okay. That's a great input. I see community, I see availability, I see value. And the goal of the presentation will also be to add a few more adjectives to this list. But it seems you already know quite a lot about what are the possible advantages of open source. Okay, so thank you for participating, and thank you for sharing your insight. And that's going to be very useful and very helpful for me to focus the presentation. So just a few words about myself, and I'm going to be very quick, but I just wanted to make the connection why I am here today sitting in front of my computer and talking about open source. I was actually born in 1982, so just turned 40. And 1982 is just 1 year before the GNU project. The GNU project is actually the original project within which the free software concept originated, and which was really a starting point for this open source movement. And I was lucky enough to have a dad who is very knowledgeable about computer programming. So I learned programming very early. You have a nice little picture of my sister and I playing video games in front of an old VIC-20 computer. So I learned programming when I was a kid, and I learned programming by actually transcribing, just typing the code. At that time, it was a basic code of open source program. Open source in the sense that at that time, the most convenient way of transferring programs from one computer to the other, or to a very large audience, or actually to print the code of the software in a magazine. So you had magazines, like the Compute magazine, for example, where you could find the source code which was printed, and you had to transcribe, to just type it again to be able to use the program. So it was really interesting, because at the time, all the programs I was actually confronted with were by definition of open source, since it was the only way. I mean, transcribing the source code of those programs was actually the only way to use it. A little bit later in the 90s, I became a little bit more serious about programming, mainly by hacking 3D video games in the C programming language. And then in the year 2000s, I started my original training, which is in physics, in theoretical physics, and I did a PhD in theoretical physics. And during my PhD, I was one of the lead developers for MadGraph, which is a very large platform for simulations in particle physics. And this platform is actually has made available to the physics community as an open source simulation tool written in Python. And a little bit later, 10 years ago almost, I co-founded B12 Consulting, which is a service firm operating today of about 40 people now. You have a picture of the team. Last month we were in Avignon for the team building, so that's a picture of the team next to the Avignon Bridge, the famous Avignon Bridge. And this team is specializing in developing innovative softwares, including developing innovative softwares for AI applications. So you see that there is a direct connection in almost every decade of my life between my activities and both open source and AI programming. A little bit of a disclaimer: this overview will be quite opinionated. I won't try to be objective, because it's quite difficult to be objective on such a topic. I will definitively be selective and not exhaustive, so I won't try to cover all the possible libraries and all possible tools that you can use to build your AI application, just because it's impossible in 45 minutes to cover all of those. I will be rather superficial. That's definitively not the goal of this session to for example, do a hands-on session. It will be quite superficial. I will be just throwing name and give you a little bit of information for all those tools, and let you discover those tools by yourself a little bit more, a little bit later after the presentation, but I will be available to help if you have any question. And I also won't enter into the debate of what exactly artificial intelligence is about and what are the differences with data science, machine learning, data engineering, MLOps, so on and so forth. I think the debate might be interesting, but that's not really the right place to have it. So for the time being, I will focus mostly on data science tools. But what are we talking about when we are talking about open source? Open source is by definition a computer software which is released under a certain category of license, a license which at least gives the copyright holder user rights to use, study, and change, and distribute the software, not only the software, but also the source code of the software to anyone and for any purpose. That's really the official definition of open source. So essentially, open source software is free. But you have to understand the word free as in free speech, okay? Free to do what you want, and not necessarily as in free beer. So that doesn't mean that open source softwares are costless or are cheap. It means that they are free of being distributed and being modified by their users. Open source software, most of the time, are developed in a collaborative manner. Not necessarily, but most of the time they are. And if you want to know more, you can go to the opensource.org website, which is really the right source of information if you want to learn more about what open source is about. But even if open source means free, it does not necessarily mean free to do whatever you want. There are actually different types of license. And if you want to have a short overview of how those different licenses are organized, I think it's nice to see them along a continuum spectrum, which is more or less ranging from very permissive license, such as the Apache license, for example, or the BSD license, and going to much more restrictive license, like the GPL license, which is definitively more restrictive. Why are those more restrictive? The biggest difference between permissive and copyleft licenses is that the permissive license allow you to do more or less what you want with the source code. You can modify it, and you can, once it is modified, you can release it the way you want without any further constraint on the type of license you are going to use, as soon as you are keeping mentions of the original software or the original library you are using. For the copyleft, it's quite different. They are forcing you to use a certain type, most of the time the same type of license as the license of the software that you have been using to build your own software. So there is a notion of variety. The license, if you are using a tool which is released, for example, as a GPL tool, you are forced to release also your own tool as a GPL tool. So there is really this big distinction. There are other distinctions between the different various open source license. It's quite a complex topic, actually. For example, if you really want to understand the difference between AGPL, LGPL, and GPL licenses. So if you are using open source tool and you are doing it seriously, I strongly encourage you to ask for professional legal advice if you want to be sure that you are actually doing it the right way and using those tools in an allowed manner, and to make sure that you understand the constraints that might apply on the tool you are building by using those open source tools. But long story short, nowadays, most of the tools we are going to talk about today are released under permissive license, which more or less means that you can do whatever you want with the tool you are building using those libraries. Okay, but why are we using open source into 2022? And here I'm trying to make the connection with this word cloud that we are building together, where you were mentioning different type of qualities that people can expect from open source tools. I listed a few. The first one for me, which is really crucial, and we'll go back to that, is really transparency. The fact that open source tools are not black boxes. I mean, there are boxes that you can look inside, and that really makes a big difference in data science. I'll come to back later. The support. I mean, a lot of people have mentioned in the survey the word community, and I think the word community is really crucial in the fact that you can expect a very good support from a very often vibrant community, which is active around the development and around the use of those open source tools we are going to talk about. And this support is actually very efficient and very often more efficient than the commercial support you can expect from proprietary tools. Another quality you can expect from open source tools is interoperability, the fact that open source tools are kind of forced by definition to be interoperable with other tools. And in that sense, most of the time, they try to implement some standards and some open standards to help for this interoperability. And this is crucial in data science. We come back to that later. Something that wasn't mentioned, at least not so much in the survey we just had, is the security and the reliability of those tools. It has been proven by dozens of studies nowadays, and just also by the very own existence of the Linux open source operating system, that open source software tend to be more secure, more reliable, and of higher quality compared to their proprietary counterparts. You also have more innovation and evolution opportunities. By definition of an open source code, you have the possibility to improve the code and to make it evolve. The stability of those codes, even though it might sound counterintuitive that if you have a tool with very large community, this tool is actually more stable, but it has also been proven by many projects that those large open source projects tend to be more stable in time than their proprietary counterparts. Something that could be also of interest for you, especially if you're in a management position, is that those tools help for hiring, for building a efficient team of developers and data scientists. Just because the fact that those tools are free means that they are often used widely in academia, and they are used by many developers during their training years. So most developers that you could hire are probably already knowledgeable about those tools. That's not necessarily the case with proprietary tools. And the last reason is just because it became the norm. I mean, nowadays, all major industry players, GAFAM, but all the other ones also are actually moving, if not exclusively, at least massively to open source tools. And something that was a little bit a dream 20 years ago really became the norm nowadays. So that's the other reason for using open source tools in 2022, just because that simply became the norm. Okay, but why are those qualities critical for data science application? The first reason, the first quality, this transparency quality I was mentioning, is that in data science and in AI project, we very often need to be innovative. We need to build innovative applications. And to me, no serious innovative data science work could be done by just relying on black boxes algorithm. I mean, if you have no clue what's really going on into those algorithms, and if you don't have the possibility to open the algorithm to look inside to see what's going on, I think it's very difficult to argue that you are doing, that you know what you are doing ultimately by building those new solutions. I think it's also important to have this full transparency for methodological, but also for ethical and legal reasons. I mean, people are talking more and more about the ethical aspect of AI and the ethical aspects of building, for example, machine learning algorithms. It's very difficult to address those reasonable ethical questions if you don't have the full control of what's going on inside your algorithm, and if you cannot look inside the engine and see what's going on. The fact that you have a large support is also extremely important in data science, because data science is a very fast-moving field. Things that were, only theoretically possible 5 years ago became practically possible 3 years ago and are just mainstream today. So it's a field which is evolving extremely fast. If you look, for example, at all the progresses that have been made in natural language processing, the level of maturity we have reached with the solutions over the last 2 or 3 years is really amazing. So since things are moving fast, you really need an efficient support. And the presence of those very large community is probably the best guarantee that you will get support when you need it. And the last thing about interoperability, it's really important to understand that in data science, the solutions you are going to build are most likely going to be assembled using a lot of different bricks that are coming from, different authors or different teams. And those bricks needs to interoperate and needs to talk to each other in a nice way. So having the guarantee that all the authors of those different bricks had in mind this interoperability when they build a solution is also something which is crucial to develop large-scale data science applications. So now I'm going to review all those tools. That was the promise of the presentation, is to really review many different tools, something like 10 of them, and to give you possible advantages of using those tools, a few tips also around those tools, and also alternatives if you want to consider alternatives. So the first tool I definitely need to talk about is the Python programming language. For those of you who don't know Python, Python is an interpreted high-level and general-purpose programming language, which has, I would say, two main advantages. The first one is that it's highly readable. a Python code is most of the time considered more readable than other programming languages such as C, for example, or the lower level programming languages. And the second advantage is that this language allows for multiple programming paradigms. So it's not only procedural and object-oriented, for example, but it also allows functional programming. And since in data science, we tend to use simultaneously different types of programming paradigms, it's important to have a single language which can fulfill those different needs at the same time. But if we really have to focus on its number one strength, I would say that's definitely its ecosystem. There is a huge ecosystem of libraries surrounding Python. So Python is not only a programming language, it's also the glue between thousands and thousands of high quality tools that you could use. So learning Python is definitely your entry point for this fantastic ecosystem of open source tools that are available. It has been released in the early 90s, 91, and it has been released under a permissive open source license, which is called BSD style license. It's actually the real name is Python Software Foundation license. It's a specific license for Python, but it's inspired by BSD licenses. It has many different distributions. I encourage you to look at the Anaconda distribution. It's a well-known distribution, which is very comprehensive, which really comes with a lot of useful tools pre-bundled in a single distribution. It's quite easy to install either on Windows or on Linux or on Mac. In terms of competitors, I definitely need to name R, which is the biggest competitor for Python for data scientists. It is preferred by, sometimes it's preferred by certain data scientists. Most of them are working in the pharma or biotech industry because R is actually an open source implementation of the SAS programming language, which is a proprietary environment. But R, its open source counterpart, it still has a lot of dominance in some specific industries. It is a really interesting programming language, but I would say that the main disadvantage compared to Python is that it's more restricted in terms of capabilities building large-scale applications. So R is a good language for data analytics, data analysis, but as soon as you want to bring this analysis to the level of really building large scales, robust, scalable applications, it starts to show its limits. There are other alternatives, like Scala, for example, which is for quite the opposite of R. It's really a language which is really focusing on building large-scale applications, which are very, very scalable. But the main disadvantage compared to Python is that it has definitely less third-party libraries when it comes to data science. And you have other programming languages, such as Julia, for example, that could also be of interest if you want to have a look at it, especially when it comes to performance. That's my tip for Python. Don't be fooled by the seemingly smooth learning curve of Python. It's easy to learn Python quickly, but it's also easy to make very bad mistakes in Python. So take really enough time and invest enough time, or ask your team to invest enough time to really learn Python properly, because it will save you a lot of time down the road. Okay, so that was the first tool, obviously, Python. The second one I would mention is Jupyter. Jupyter is a web-based notebook environment, and Jupyter has been extended to what's called Jupyter App, which is a complete environment for developing, for running data analytics studies. It's extremely useful for developing and sharing experimental data science work. So if you want to experiment with different techniques, with trying different libraries and things like that, it's really a useful environment. It has all the convenience of notebooks, where you essentially type the command line you want to execute, and then you press enter and you get immediately the result, and then you type another command and you see the result, and you can get nice visualizations which are already integrated. So those notebook oriented tools are extremely useful for investigations, I would say. But this interactivity is also their weakest point. it's very difficult to run those tasks asynchronously, for example. So if you start a task by executing one command line in a notebook, and then this task is taking a lot of time, and if you want to execute another one, you start to run into concurrency issues. So the cell order is also could also be annoying. So, for example, if you execute the cell in different orders, you will get different answers and different results. So it really makes long notebooks difficult to handle. And I definitively don't encourage you to use notebooks to develop proper software. So notebooks are there and should be there only for investigation work, but not to develop proper applications. For developing proper applications, you should just use the standard Python tools. And obviously, code editors such as, integrated development environment, IDEs. Two good ones are PyCharm and even probably better VS Code nowadays. And both of them know, at least VS Code, include some interactive code cell execution, notebook capabilities. So you could have the best of both worlds, I would say, by using VS Code. You could at the same time really develop large-scale applications in Python, I would say the standard way, by just typing source code and building those Python packages inside VS Code and debugging them, and running notebooks such as Jupyter notebooks also directly from inside VS Code. So I encourage you to look at the VS Code and this compatibility mode with Jupyter notebooks. Okay. So now, if we are leaving this area of generalities about Python and how you are building Python applications, the first large-scale library I think you will probably need to be confronted with if you are building data science application is definitely NumPy. NumPy purpose is really to circumvent one of the biggest issue with Python, is that Python, being a very high-level interpreted and dynamically typed language, it's also really inefficient, and the performance of Python is really bad. If you want to do really low-level calculations, for example, if you had, I don't know, 1 million numbers that you want to compute the average of those 1 million numbers, if you do it in pure Python, by just for example making a for loop and summing all those numbers, it will be really, really inefficient. So as soon as you are starting to manipulate large arrays of numbers, you should definitely use NumPy. That's, I would say, the standard way of manipulating large arrays of numbers. NumPy solved this challenge by actually implementing in C and sometimes C++ very large array types, multidimensional array types, so matrices, tensors, and so on, and all the associated manipulation methods. So you have the possibility to manipulate those multidimensional arrays with plenty of highly optimized manipulation methods. It has very impressive performance. You can look at the charts at the bottom left of this slide. You see that as soon as you start increasing the size of an array, very quickly NumPy actually display its main advantage, which is almost a factor of 100 improvements in terms of speed compared to naive Python. And you see that NumPy is somewhere in the range of C++. Or other compiled languages. So if you are using NumPy properly, in principle, there is no reason your code should be significantly slower than the C++ equivalent. NumPy has been released in 1995 under a permissive BSD license. In terms of alternatives, there are not so many alternatives. You could actually use NumPy, which is a way of compiling Python code, or even QPy, which is a way of building GPU accelerated code similar to NumPy directly in Python. You can even use PyTorch. I will come back to PyTorch. It's a large deep learning framework, but you could use PyTorch to do tensor manipulations in Python in a very efficient way. But definitely don't try to do this by yourself by implementing for loops in Python, because that would definitely result in a disaster as soon as you start manipulating large arrays. When it comes to doing numerical analysis and statistics on those large array, you should definitely consider, the SciPy scientific library. SciPy very often comes together with NumPy. I mean, often we say NumPy, SciPy, because they are really integrated at a very low level together. Essentially, SciPy is only manipulating NumPy arrays, but they are providing a lot of more evolved calculation methods, which are more focusing on statistics and numerical analysis. So you could do signal processing, you could do integration, differentiation, interpolations, you could have optimizer, including under constraints optimization, statistical function, solvers for ordinary differential equations or partial differential equations. So you have all the possible numerical analysis methods you could imagine, which are already implemented in SciPy in a very, very optimized way. It's extremely reliable, it's quite fast, and it's an excellent choice for your first prototype. It has been released in 2001. It's quite old. It's very, very well tested. It has been used in plenty of critical applications by the NASA or by other very large organizations. So you can really rely on the results that are provided by SciPy. There is no real alternative to this library. It's so well known and so widely used that there is no real alternative, but you can find specialized packages, for example, StatModel for advanced statistics or DICO for optimizations. But if you really look at I would say, what is the right package to attack a numerical analysis problem, then definitely I think all data scientists would agree that SciPy is the answer to that question. Okay, manipulating large numerical arrays, you definitely need to rely on NumPy. But as you know, your data is not only numerical arrays. You sometimes have to also manipulate large arrays of strings or large arrays of categorical variables, those kind of things. And to achieve that goal, pandas, which is really a big layer on the top of NumPy and SciPy, is the right approach. So the key notion at the root of pandas is a notion of data frame, which is essentially a simplified in-memory database that you can use, that you can query, that you can perform all the standard operation you can imagine performing on a relational database, such as join, such as grouping, such as merging those tables. In some sense, you could see pandas as an extremely high quality Excel, which is made available for being used inside Python. Okay, so all the join tables and all the things you could imagine to do in Excel, you can do them in pandas in a programmatic way. It is also an important library for data science because it can read and output data very efficiently in a lot of different formats. It can natively read Excel files, it can natively read JSON formats, and it's extremely useful also to output the data very efficiently in any kind of format, including all the major database formats. It's a default library used by 99% data scientists, I would say, for data preparation purposes. And it can even be extended to allow for parallelization. So by default, pandas is only for in-memory. So the big assumption is that you can store all your data into the active memory of your computer. But if you cannot, there are solutions to parallelize pandas relatively easily. And you can look, for example, for Dask or for Modin, which are extension of pandas to do to achieve the same results, but on much larger data sets that needs to be parallelized. It has been first released in 2008, also like all the tools I'm mentioning under a permissive license. It has no real alternative, but similar objectives, essentially manipulating very large data sets of various types of data can be achieved either by using SQL queries, so loading your data into SQL database and just using plain SQL, and more data scientists tend to rely again on plain SQL requests to do that, or by relying on, for example, all the Apache suite of tools, such as, for example, PyArrow to access Spark type of calculation running on Hadoop server and this kind of big data technologies. But if you want to just discover the world of Python and data science in Python, I think Pandas is definitely the right entry point for manipulating those relatively large-scale data sets. Very often when you are doing data science, one way or another, you have to plot things. You have to plot things at the very first stage when you discover the data, trying to make sense of what the data is about. But you also need to plot things when you are, for example, training neural networks and you want to see, the progress of your training, those kind of things. The standard library has been for plotting things in Python has been for many years a library called matplotlib. It's actually the de facto standard for plotting in Python. It's fully compatible with NumPy, SciPy. It's very reliable, very flexible. It can sometimes be a bit cumbersome to use, and the biggest disadvantage is that most of the time, by default, the look and feel of the plots which are produced by matplotlib is not great. It looks a bit dated. But there is a solution for that. There is a package called Seaborn, which is essentially an independent library which has been built on the top of matplotlib, which really help you building nice plots just using matplotlib. It has been released in 2003, also under an open source license. And in terms of alternatives, there are a few. Bokeh is one. There are also tools such as Plot9, which has the big advantage of using the same syntax for plotting as ggplot2, which is a very successful visualization package for R. But you have to be careful that Plot9 is in GPL license, so it might have some consequences on the license you are allowed to use for your own software. In terms of the tip I would provide for visualization, don't reinvent the wheel. Just browse to matplotlib gallery. If you go on the matplotlib website, we see that there is a gallery with hundreds, if not thousands, of examples of different plots you could do, and just take one of those examples, tune it a little bit for your own purpose, and start from there. Don't try to do your own plot starting from zero with matplotlib because it's uselessly cumbersome. Okay. Now comes machine learning. So in data science, obviously, we very often want to perform some trial or some type of machine learning. And if you want to start studying or practicing machine learning in Python, every data scientist will agree the right entry point for classical machine learning. So for all the classical machine learning algorithms, including regression, classical classification, random forest, clustering algorithm, everything essentially but deep learning. The right entry point, the right library for doing this is sklearn, scikit-learn. It's a free software machine learning library for Python, which has been designed again to interpret nicely with NumPy, SciPy, or even Pandas. It's a quite generalist library, so it's not really focusing on one type of algorithm, but the goal is really to give you access to a huge variety of different classical algorithms that you can try. It's very often a good first try when you are trying to perform some machine learning prediction, for example, or some classification exercise. Its main strength, from my point of view, it has a very strong architecture. So all those different algorithms are actually structured and bundled all together under a very strong architecture. So you have those notions of pipes and so on that can be connected one with each other. So it's very convenient to use, and it's actually a good practice when you are building your own algorithm. So if you ever need to build your own machine learning algorithm, it's a good habit to try to follow the sklearn standards in terms of structuring your tools, so that people can use them easily, because most data scientists are used to use sklearn for classical machine learning exercises. So if you follow the same conventions, then they will be also easy for them to use your own tool. It has been released in 2007 and is mainly maintained by a group of academia researchers in France by INRIA. It has no real alternative. To my knowledge, there is no completely generalist machine learning library in Python, such as sklearn, but there are a lot of other libraries which are much more specialized. For example, if you look at gradient boosting, so a subclass of of machine learning algorithm, XGBoost is a very well-known library which is very interesting to use. Okay, almost there. Obviously, we are talking about data science, so there is no way we cannot talk about deep learning. So for deep learning, you have essentially two possibilities. One is TensorFlow, which is a very established framework to build deep learning models, and PyTorch, which is its biggest competitor and is biggest alternative. So PyTorch or TensorFlow, I mean, you can have endless debate between data scientists about which one is the best one to build deep learning models. But I would say that no, those are most likely the two major alternatives you can consider for building your own deep learning models. TensorFlow is built natively in C and a set of different low-level languages for performance reasons. So you need to access TensorFlow through a layer which is called Keras. But this layer of Keras, which allows you to access directly TensorFlow from Python, is actually bundled with TensorFlow since it's version 2. TensorFlow is highly optimized to be trained on GPUs and TPUs. And it's something which is extremely difficult to do. So, except if you are interested for academic reason in rebuilding such a tool, I strongly encourage you to test TensorFlow or PyTorch instead of trying to invent the wheel for yourself, because those tools are extremely complex to develop. You also have nice complement to that. For example, you have TensorFlow.js, which allows to execute TensorFlow models inside the browser, or you have TensorFlow Lite, which is a way of executing TensorFlow model in a compressed mode on mobile or edge devices. So those could be of interest. It has been developed by Google back in 2011. So it's one of the first major open source deep learning framework. And it has been released officially as an open source project in 2015, yes, under the permissive Apache license. And as I've said, its main competitor is PyTorch, which is maintained by Facebook teams mostly. PyTorch, when I first wrote this guys 2 years ago, TensorFlow was a clearly winner when it comes to the maturity and the robustness when it comes to developing production-ready softwares. But nowadays, I would say that they start to be essentially at the same level. And if you look at all the major cloud providers, they are now providing direct access to both PyTorch and TensorFlow for production purposes. Just one tip: using GPU is really crucial when you are doing deep learning. I would say that nowadays it's almost unavoidable to use GPUs if you want to have reasonable training times. But you can definitely try GPUs online or in the cloud, but be careful that this can be extremely expensive to use cloud resources for doing this. There are some efforts going on to try to have some cloud resources local in Belgium, and we can talk about that if you want, for achieving GPU calculations. But for now, one possible solution is just to use also local GPUs, so buying a few GPUs locally and running those calculations locally. It's not necessarily a bad solution. And if you are using an Apple or a Mac computer, nowadays the M1 and the M2 laptop versions, they are supporting GPU acceleration for TensorFlow natively. So that can be of interest. Okay. Now, to finish, two libraries which are a little bit more specialized in terms of application scope. First one is OpenCV. It's really a very mature toolbox for building real-time computer vision applications. So CV stands for computer vision, and opens for open source. So it's an open source computer vision library. It's a little bit the equivalent of SciPy. I would say it's the good default library to look into for all the standard computer vision tasks you could think of. It both implements relatively low-level functionalities, for example, for editing images or for detecting contours, manipulating large matrices, which is useful for computer vision. But it also nowadays implements more high-level machine learning based applications such as stereo vision applications or gesture detection algorithms. And all those are nicely implemented with GPU acceleration. So it should really be considered as the standard out of the box solution for anything that is linked to computer vision. It's quite an old library. It has been released in 2000 by Intel. Under an open source library. It's actually the grandfather of all the open source libraries for data science. And in terms of alternatives, there are not so many alternatives that are as generic as OpenCV, but you could mention scikit-image, which is a subclass of all the sklearn algorithms that are focusing on computer vision, and Pillow, which is a less powerful CV library for Python, but which has a few interesting algorithms implemented. There are also other libraries which are implemented for more specific application, and I wanted to mention Open3D for 3D data processing, because more and more people are interested in 3D data processing with machine learning techniques, and Open3D is an interesting choice for that. Last one, difficult to discuss about machine learning without discussing a bit about natural language processing. And nowadays, if you want to do natural language processing in Python, I think a very reasonable choice is spaCy. It's a good, recent and modern library for advanced natural language processing in Python. It has actually been written in Python and Cython, which is a way of compiling Python code, so making it more efficient. It provides low-level methods to understand our NLP tasks, like tokenizing, stop word removals, and so on. So all the standard tasks that you are performing in NLP before actually feeding the more advanced algorithms. All those tasks can be done using spaCy, but spaCy also provides a connection to advanced statistical models trained by popular deep learning libraries, such as TensorFlow or PyTorch. It supports training languages, including Dutch and French. So it's particular interest for Belgium. And it comes bundled with several successful pre-trained models, such as the now infamous transformer models like BERT or others. It connects nicely with popular online NLP model repositories such as Hugging Face. And like all the other ones, it has been released. It's probably the most recent one, I believe, on this list. It has been released in 2016 as an open source project with MIT license. Its most notable competitor for NLP in Python is called NLTK, Natural Language Toolkit. It's quite older and it's more oriented towards research and teaching. So I don't necessarily encourage you to use NLTK if you can use spaCy instead. One tip is that if you are interested in NLP, be careful that nowadays modern NLP is extremely resource intensive. So it's difficult to imagine that you would build your own model from scratch. Nowadays, more and more people are using transfer learning solutions to retrain or to post-train existing models which have been trained on very large corpus of existing text. Okay, some final words, because I see that I'm almost running out of time. This short overview will cover a central part of AI and data science project, mostly the machine learning part, if you want. But definitively, AI is not only, developing an AI solution is not only about developing a machine learning algorithm, it's also about doing all the upstream data engineering, doing all the software development to give access to users to those machine learning algorithms. It's also about deploying efficiently those algorithms and making sure that they can be retrained. It's also about selecting, possibly automatically, the right machine learning algorithm, AutoML, and developing good user experience and good user interfaces. And all this I didn't mention, but there are tools and very good tools in Python to do that. And it will be the topic of a different presentation. But just be careful that what I presented today is just what's needed to develop the core of your solution. You need much more to develop the entire solution. It might be intimidating to start working with open source tools in such a vast field. So if you want to have a very short work plan, an actionable one, I would say one, start dedicating some time to learn Python seriously. When I say learning Python, it means also learning NumPy. When you are comfortable using Python, start by reading some hands-on introduction. There's this book called Hands-on Machine Learning with Scikit-learn and TensorFlow, which from my point of view is one of the best books if you only want to dedicate a few days studying machine learning techniques in Python. And then the most important advice is learn by doing. Pick up a real world challenge, which, for example, a real business problem you are confronted with, not a Kaggle contest. So be careful not to only use academic data sets because you need to learn a lot of things about real world data and work on solving it by identifying and learning to use various libraries along the way. And the most important advice after all those is to get support. I mean, this is the main strain, as we have emphasized several times, and I'm looping it. Now, the main advantage of open source tool is the community. Ask questions on specialized platform, participate to meetup events. There are plenty of nice meetup events organized, including on Belgium. You can also rely on I think on a nice community of local experts, and AI4Belgium is really a nice place to get in touch with those local experts. I mean, B12, my company, I think has quite a few local experts, but there are plenty of other nice companies around that could help you with the right use of those open source tools for AI. And I thank you for your attention. And I think we still have, sometimes have maybe 10 minutes for questions.
Thank you so much, Michel. It has been very concise and very interesting. I think, yeah, it makes clear what are the tools we should use in order to begin with data science and AI. So if you have questions in the audience, please put it on the chat or on the YouTube chat, and we will see them and ask to Michel. I have a question from Alain Coletta from the AI4Belgium team, who just joined AI4Belgium 2 months ago. It is about the TPU, so the tensor processing unit. You have talked about the GPUs. Yes. Can you compare them? Do you use TPUs in terms of pricing and efficiency? Could you elaborate a bit on that?
Yeah, so TPUs, so really just to summarize, GPUs are essentially specialized processing units which are specialized for handling graphical tasks. But it happens that handling graphical tasks is essentially about manipulating large arrays of numbers, and manipulating large arrays of numbers is what you need to do for deep learning. So that's why GPUs have been reused and recycled to do deep learning. But if you want to only do deep learning and you are not necessarily interested in the graphic applications, then you could imagine to use TPUs, so processing units, which are really highly specializing in manipulating tensors, which are high dimensional arrays of numbers. TPUs, it's still a little bit of a new field. I mean, there is not that many TPUs available commercially. And from the first tests that we have been performing and for what we could gather in terms of information, the price to performance ratio is not yet really in favor of TPUs compared to GPUs. I mean, so except if you have very specialized and very, very large amounts of data, really, big data, and you are part of a very large player, it's unlikely that it makes sense to buy a TPU right now to do I would say, a classical deep learning exercise. I mean, GPUs are cheaper and easier to access, mostly because they are used for other applications than deep learning. So I would recommend to first look at GPUs before investing in TPUs.
Thank you. Michel, we have another question about Europe and AI Week from Thibaut Tercelin, because I used the background there. So yeah, it will take place in March. We must confirm the date. It will be probably the last week of March from 27 to 31. And yes, it is the opportunity to present and to showcase what we've done in Belgium. So there is no difference between the AI Week, European AI Week. It's the same project, and the purpose is, yeah, to showcase what we do in the region, in Belgium, and we invite the other to participate, but we promote Belgium through this event. Didier Cornel, can you, yeah, you can have the floor.
Yes.
Yeah, we don't hear you.
Yes, thank you. This is very interesting. Thanks a lot for all these explanations. I have one question. It's a little bit out of the scope, but is there a place online where you can find, yeah, let's say, open software in like you were describing, created by public institutions, especially Belgian or European ones, of course? Thank you.
Thank you. That's a great question. I know there are ongoing efforts, for example, by the Trail group, trying to build such platforms, really specializing on, making available tools built by the academic community and the public sector community. To my knowledge, there is no yet a well-established standards. Some universities and some research groups are trying to have their own repositories for that. But I don't think that, at least in Belgium, there is a real central repository, but there are efforts ongoing to try to achieve that goal. But to my knowledge, there is no such a single source of information that would be specializing exclusively on open source applications built by the public sector. But you have plenty of repositories online, starting with GitHub, obviously, but plenty of others where you can find source code for open source application related to AI.
We could also refer to the AI4U platform, which is now AI for Europe in this new version, who aims also at developing some open source available building blocks, but not only for the public services. And it is the same for Trail. You mentioned, Michel. Trail are the trusted AI lab, meaning all the labs working on AI in the French-speaking universities in Belgium, and the research center like CIRIS, Enairo, Multitel, CETIC are also participating to this community, very active, academic, but also wanting to do the technology transfer towards public services and private sector, mainly the SMEs. So in Flanders, you have also many initiatives, but not yet a single point with all available data. That's a good idea for AI4Belgium by BOSA. We could maybe set up this. The main focus could be on the sandbox, probably. Then a question from Bartel Rijgaard. The open source tools you mentioned, Michel, were related to the perceptual aspect, so computer vision, NLP, and yeah, could you elaborate on speaking, writing?
So NLP is not
GPT-3 and things like that.
Yeah, NLP is not only about understanding text; it's also about producing meaningful answers to questions. For example, we have been building, for example, a chatbot which is trying to reproduce some characteristic of old books from Molière for the French National Library. So the tools, especially I was mentioning, but also the transformer-like model like BERT or GPT-2 and so on. I mean, all those modern deep learning models are specializing not only in understanding text, but also in producing meaningful answers and meaningful content, for example, summarizing large text. So I would say that at least for NLP, in terms of executing actions, those models incorporate those notions nowadays.
Yeah. Thank you so much, Michel. I want to thank also Alain, Jasper, and Alexander Vika, who helped organizing this webinar. Thank you so much. Thank you also for participating to the AI4Belgium Advisory Board, and see you next time. So we will share with you the date for the next event. It will be probably end of December, and it will be nice to meet you again. And do not hesitate to share the invitation with all the community, or to register on the AI4Belgium channels on LinkedIn, YouTube, or the website. You can register also to have the newsletter. Thanks, Michel.
Thanks.
Have a nice afternoon.
You too. Enjoy the afternoon.
You.
Bye-bye.